All right, guys, here we go. I'm not too thrilled with the PowerPoint idea. So, I tried something and flat out it stunk. So, it's the way it goes. So, we'll try something different for my next unit. I don't know. I'll try something different every time. So, here we go. So, we're going to go rules of differentiation. So kind of a recap, okay, guys? And you guys did a really good job of dealing with the fact that the derivative is the limit as h approaches 0, right, of the function x plus h minus f of x all over h. Notice I'm getting better at writing on this. Takes a while to get back into it. So this is the limit definition of a derivative. Now remember, a derivative is when we find a different derivative, we're differentiating it, or uh, the process is called differentiation. So that's kind of the idea. And remember, it's just based on this. And if you guys remember, that is really like the this is slope on steroids. Okay. So this bad boy is slope on steroids. And we write it multiple ways. We talked about it last time. Dy dx is one of them. F prime is the other one. Y prime. They all mean the same thing. They're the slope of the secant line using this definition. This is the good part. Rules make this thing really, really short. And we talked about it the first day we talked about this. I gave you guys a little recap, and we got quite a few rules. So, what you guys are going to learn in this particular unit, we're going to call power function, which what we call the power rule. Sum and difference rules, those are just like if we have more than one together, like x squared plus 3x minus 2. There's a sum, there's a difference. It really means that you're going to use the power rule multiple times. Product and quotient rule is what we'll tackle next week. These are a little bit more iffy. Negative integer powers, which is a little different. You're going to have to remember some negative exponent rules, like, x to the negative 2 is the same as 1 over x squared. So this may take some little review, and then we got to deal with like higher order derivatives, like first derivative, which is f prime, then f double prime, which is the second derivative. We could go f triple prime, the third derivative. So we just kind of keep working our way through. Okay. And why? Because these rules help us find derivatives in a much more efficient way than that big old ugly equation. So there's the setup, guys. So this is the constant rule. So if I have something like this right here, let's just say, so basically what they're saying is if I have the derivative of this idea, let's just kind of, let's just kind of talk about this for a minute. So u, which is this guy right here, is a differentiable function of x. So here's that whole idea. We are doing the derivative, okay? So derivative, I spoke too soon of being able to write better. Derivative of u with respect to x. Okay? So we're using u, not y, not anything else. So this really, if we look at it, isn't going to be dy dx. That's not what this is going to be. This is going to be the derivative of u over dx. Or we could write it as u prime. Guys, kind of see how that changes? It depends on what they're asking us. C is just a constant. So this is like the constant times u, and u is a function. Okay, all right. So this is the derivative of the constant times u, which really means the constant, and now that I've marked it up horribly again, which really, I never can hit that. There we go. Which really spreads out into two different pieces here. This derivative of x times the constant times c, the constant times u, we can really move the constant out. Constant just means a number, guys, like 1, 2, 3, 4, 5, 6. And then we're going to multiply it by the derivative of u with respect to x. So let's just take something like 5x squared. Okay? So really what this is, if we want to find the derivative of this, the derivative of dx, let's say, this is actually supposed to be u, it's supposed to be u, we have this piece of information, which in turn turns into this, 5 times du dx, which is the derivative of u squared. Okay, so we've got to find the derivative of u squared. We don't know what that is yet, and that's what we're talking about. So basically all we're saying is that the constants can be multiplied by your answer. Okay, all right, so let's take that a little bit farther. Where's my power rule? Did I move it? You know what? Let's go back. I'm going to go back to here because it seems like I'm missing the slide, guys. And if I am, I'm sorry. So where's the... Yeah, I don't know what happened. I feel like I deleted a slide by accident. All right. So let's just talk about the power rule. So here's the power rule. Let's just take my information here. Let's just say I have... let's just say we got this. We got 5x squared, right? So here's the power rule. We're going to multiply 2 times 5. So 2 times 5 times x to the second minus 1. So let's clean that up. And we're going to get 10x. That's my dy. Let's just say this is y. That is my y prime. Now let's look at it as the constant rule. So if I did it like the constant rule, this would look like this. This would be 5 times 2 times x to this 1. 2 minus 1, which 2 minus 1 is 1. 5 times 2 is 10. So this is really what we're saying, and there's a bunch of ways to write this. So if I have this function f, and the function is this, a times x to the n, my f prime is this, n times a times x to the n minus 1. Let's kind of take this idea right here that I just wrote in there, and let's match it up with what I did here. A to the x, a times x to the nth power. A times x to the nth power. How do I get the derivative? N times a, 2 times 5, times x to the n minus 1. N is 2, 2 minus 1 is 1, and that's how I come up with that. This is the rule. This is the power rule, and it can be applied multiple different ways. Okay? All right, so the sum and difference rule just really means this, guys. It means that when you have two different pieces of the function, I don't like yellow. It doesn't stand out very good. When you have two different, I said I don't like yellow. I don't want yellow anymore. Well, this is just fighting me today. It's been doing this all day long, guys. All right. Nope. Why are you doing this to me? Okay, we'll go with that. I don't know what's going on, but so if you have two different pieces of your function, and it doesn't matter if it's plus or minus, that's why there's a plus or minus right there. You just take the derivative of the first one and you add it to the derivative of the second one. Okay? So remember, differentiable at every point means it's continuous. So this is really what this ugly looking term is really saying. We're going to do the power rule multiple times. Look, here's why. Here's my function. Each one, you just take its separate derivative. So what we're going to do, and if that's what they're doing here, so let's kind of look at this, and I'll kind of mark it up as a highlighter. Look, x to the fourth, they're telling you to take the derivative of x to the fourth. Let's do a different color and see if it works. Oh, it's not. I don't know why it won't change colors for me today, guys. There we go. That one is telling you to take the derivative of that one. And then this one here is telling you to take the derivative of that one there. And this one at the end is telling you to take the derivative of this one here. Okay? So really the sum and difference rule, this guy, just tells us to take each individual derivative, which, since they're powers, we can apply the power rule to. So we apply the power rule to x to the fourth. So I'm going to off to the side because they skip some steps because they just assume, oh, you guys got it, but I want you guys to see what happens. So I'm going to do x to the fourth. X to the fourth. Its derivative, so the derivative of x to the fourth is equal to 4 times 1 to the power minus 1, which is 4 minus 1. So 4x to the third. So this will be 4x to the third. There it is right there. So let's talk about this one here. They did it as a constant model. I'm going to do it this way. So let me do a different color, if I can even get it to do that. So we're going to do 2x squared. Okay, so we want the derivative of 2x squared. I'm going to do it as the power rule. My a is 2, n times 2. 2 times 2 is 4, x to the second minus 1, which turns into 4x, and that's it. Look what happens here. 2 times 2 is 4x. There it is. There it is. Okay? Now, let's take this second one here. Or, sorry, the third one. I'm going to do that we'll do that one in black here. So let's take that one, and I get 3/4 x. Now, I'm going to write something in a different color for you guys here. Remember, this is to the first power right here. So when we get this, and I want the derivative of this thing, remember I'm doing 1, the power, n, times the constant in front. So 1 times 3/4 is 3/4. But 1 minus 1 is 0. And so x to the 0 power doesn't exist. So my derivative of constants is 3/4. It's just the number itself. Now, what about this 19 right here? That 19 poses a specific problem for people because you were never taught to write this. 19 has a variable with it. It's just to the 0 power. For the purposes of the power rule, you have to theoretically see this. Remember, the power rule takes the n and multiplies it by the number, the constant out front. What's 0 times 19? It's 0, so it just disappears. So these constants just disappear and turn to 0. So that is my derivative. Way shorter than that crazy formula. It took me a little longer to show you, but I wanted to show you piece by piece. So that is our power rule. Doesn't matter what we're dealing with. So let's do this one a little bit quicker. Here we go. Let's write this one out a little bit. I'm going to take this one and I'll do it right here. So I'm going to find dy dx here. Okay? So dy dx, so I'm going to do that right here, guys. And I'm going to use the power rule. I'm going to write the power rule out. So it's going to be 4x to the 4 minus 1 minus 16x to the 2 minus 1 plus 2 plus 0 to the x to the 0 power. That's for this guy right here, okay, because that's our whole thing. So this is going to disappear. So what do I get when I clean this up? I get 4x cubed minus 16x. 4x cubed minus 16x right here. Okay, so I'm sorry, that's right there. We're going to do something a little bit different. So now we're talking about horizontal tangent lines, all right? We're talking about horizontal tangent lines. A tangent line is a curve. A tangent line is based on a curve. So if I look at this, I got a horizontal tangent line right here, and I got a horizontal tangent line right there. Flat lines have a slope of 0. So when we're looking for horizontal tangents, we're going to occur where the slope equals 0. So we set this equal to 0, and we're going to find, get it, 3 points, 1, 2, 3, that equals 0. And we do that by solving an equation algebraically. And we get this at the horizontal tangent lines right here. So all we did is we factored out a 4x. We set each one equal to 0, the 0 product rule, and then we solved each one. We can talk about this one in class if we need to on Monday, because I won't be here today. So that is what you're doing. This is kind of an intro to what we're getting ready to do, okay, guys? So if you have questions on this one, it's okay. Now, you guys are going to be working on worksheet 10 here. Worksheet 10, let me just kind of find it for you guys, because I want to look at it real quick for you. So I'm actually giving you a preview of what we are doing. So worksheet 10 is what we said, okay? So worksheet 10 is this guy right here, all right? So these are all going to be power rule stuff. So we're just going to work on our power rule right here. So using the power formula right here, you guys can kind of see that. You know what? I'm going to open it with Cami because I can. So I'm going to open it with Cami here, and we're going to write on it. So this is 10. This is a little bonus feature for you guys, all right? So I'm going to write on this one. So this kind of this example up here is the example that I just gave you. So you're just using the power formula that I gave you to find the derivatives on all these functions. They may get a little ugly. Don't forget, this is the hard ones. These are all the little algebra tricks that we're going to just have to work through. Like the square root of x is really x to the 1/2. So that's a big one you guys are going to have to know, and that's going to come into play right here. You're going to have to multiply this one out. I think I'm looking through tricks right now, guys. You're going to have to multiply this one out. You're going to have to multiply that one out. I want to see what you guys do with that bad boy. This one, don't forget, it's going to be x to the 3/2 power. No, 2/3 power, sorry. The power goes on top. The radical goes underneath. That's why this became 1/2. So that one's there. You guys can work on that one. So now what they want you to do is you're going to find the slope, which means you have to do the power rule first. Power rule. Sorry for the writing. Power rule first. And then you're going to plug in x. So you got to find the derivative first and then plug in x. And then here's your lovely little friend again, the definition of a derivative to find your f prime, which means that you got to use that big ugly equation. Here's all the answers. Work your way through it, guys. Good luck, and we will see you on Tuesday.